As you can see, I'm going to be talking about COBOL. A quick run through on what we'll speak about here, quick introduction to me, introduction to what's going to be happening in the talk, which is kind of this now. Quick overview of mainframes and then COBOL in general. And then we'll look at how to carry out a COBOL review, what sort of things you can look for, what you're likely to find, whatever tooling you can use to find the issues and make life easy for yourself, and then how to report security issues for something that's worked with no problem for 20 years. So that's me. I used to be a software developer, did a bit of software development in the financial sector, which is really what got me into security and how I learned about horrible things like mainframes. After that, I became a pen tester and security consultant and started doing far more, I guess, proper security stuff, code review, pen testing and stuff. Right, mainframes, I know they sound obscure or weird, but there's a surprising number of them still in use and existence. Generally throughout the financial sector, they're still doing sort of vital services, moving huge amounts of money around. And they have a surprising amount of power compared to the typical server. And you will occasionally hear people ask why are they still here, why haven't they been replaced with something modern? I know about an organisation that replaced its mainframe. That project took a year and a half, cost several tens of millions of pounds, and it was a non-trivial project to replace some of those systems. And a lot of the things that they're still doing now, it's they're still performing a vital sort of function as part of a lot of financial organisations in batch processing and overnight kind of stuff. They've got much more processing power, faster processors, huge amounts of memory capacity. And I guess they were the sort of birthplace of this multi-threading, multitasking, multi-processing kind of thing that we all take as normal nowadays. COBOL is something you might expect to be difficult or obscure or tough to read, but it is surprisingly simple. I guess it looks like a bit like BASIC, but with full stops at the ends of lines. It's very readable because it was intended to be that way. So somebody with the right knowledge and decent sort of level of programming skill and a few sort of tips on what to look for can perform one of these code reviews. And it will impress people because other people perceive it as difficult, and it's really not as tough as you might think. COBOL kind of dates back to the era when all programming languages had a name that sounds like a robot from a 50s sci-fi movie. It's the second oldest language still in existence. It's a bit newer than Fortran. And it was designed to help normal people who didn't understand assembly and weren't trained mathematicians to do programming. There was an original intention that errors will be almost completely removed if you come up with a more readable language. Similar to the aims of the waterfall method and structured programming and agile software development and pair programming. It's one of the early attempts to completely eliminate errors. And so it had this form where it was intended to be very readable for regular people, Back in the days, I guess when people first would see A equals A plus 1, it makes no sense to a non-programmer. And so COBOL was intended to be more readable with this add A to B giving C kind of syntax, which is kind of readable, but most programmers found it too much typing or counterintuitive. And so radical additions, A plus B equals C, were kind of introduced to supplement or add to that syntax. I'm saying reducing typing. In the early days, a lot of these things were written on kind of squared paper sheets that were turned into punch cards and fed into a mainframe. And as I've said earlier, there's a lot of these things have been running and in place for several years, and you will still see it, usually in places that deal with money, and a lot of the time lots of money. And it's not unusual to do this kind of code review and find a date on when the program was introduced and find that the code is older than you, older than anyone on the team reviewing it. A lot of the time, although I showed you that first black and white picture of guys in lab coats looking serious, not all mainframes are like staggeringly old. These things still are in production, and companies still make marketing material that makes them look dramatic like that. And you will find some of the larger financial organisations introducing new mainframes or replacing existing mainframes, as it's just easier than rewriting the code to run on a server, I think, in a lot of cases. So the jobs aren't like, I guess, not as uncommon as you might expect. You will come across this stuff that needs looking at, and in a lot of cases has never been tested, never been reviewed. The reasons you might want to do a COBOL code review is that the general idea that this has never gone wrong before isn't really a guarantee that nothing will go wrong in the future. A lot of this stuff was written under oldie-worldy kind of assumptions that network sniffers hadn't been invented. There was the way to access the computer room was to get through a locked door, and you'll find in a lot of cases that user input is just trusted in some codes, or that files are just assumed to be correct because they've been fed in on the network. So I guess in a lot of cases that's like a good reason for the code review, and also the kind of thing you'll be looking for. You'll be testing those assumptions and looking for code that's, I guess, built on shaky assumptions. A lot of the time, you might find this is the first time the code's ever been reviewed. So if you are getting to do a code review, do sort of speak to the people in advance. Make sure they're not planning to just give you access to a mainframe terminal. Ideally, you would want them to provide just the files for you to look through so that you can search them properly with real tools. And you can find out more information about this stuff on the IBM website. Has got a lot of old and new videos around how these systems work and how to write the code for them. And you can see changing fashion through the decades as you watch the videos. As you do get to start the review, the COBOL programs come under this I'll read the bottom part out for you because it's obscured by the camera, but they split into these parts that are always there. The identification division, which is the name of the program, who wrote it, and all the metadata that could be important for the age of it, what it's meant to do. The environment division, again, where it's meant to run and how it should run. The data division has the sort of what it's called the file section and the linkage section, just describing where its inputs come from, what data it uses. And that obscured part at the bottom is the procedure division, which is generally, I guess, sort of classic structured code, or should be structured, split up with lots of go-tos, but very much procedural kind of codes. As I said, in the old days, it used to be all written out by hand on these very rigid kind of structured sort of approach, giving line numbers on the cards and detailing all the input on the cards. And it would have been some operator's job to transform what the programmer had written on there into actual punch cards to run on the machine. Now, of course, things are much more modern, and it looks like that. Which is partly the reason you should try and get the files if you're going to do a code review, so that you're not sitting trying to work out which shortcut keys to use to navigate through. So, as I said, you will ideally need the code in proper files that you can read on your own machine, some sort of decent IDE to read them. There are a few tools that will review the code for you. I know Checkmarx and Veracode both do this, but they are paid for. VCG, I've written that. I'm not claiming it's perfect, but I am claiming it's free. And the things that you will need to look for are those sort of assumptions that I was talking about earlier, of just assumptions that files are completely safe, that a user won't type a quotation mark in some user inputs. The problems are slightly different from web or desktop applications, but some of them really are not that much different. You might have sort of issues convincing someone that a 20-year-old system they've had no problems with ever is vulnerable. But we'll kind of look at that a bit later, but it's generally from the assumptions made in the code and from those trusting user inputs. Some of the things you can find, COBOL has variable lengths, so you'll find that longer variables being copied into shorter variables. That's kind of some old assumption where a programmer's decided this amount of money is never more than 2 digits. I'll provide 4 digits to capture the user input. It's future-proof. And then later on you'll see it copied into some other variable where somebody's decided, okay, it's never more than 2 digits. I'll use 3 to make sure it's future-proof. And so you will find different size variables copied to each other. The horrors that will be familiar to C programmers, it's got signed and unsigned variables. And it, like C, it just assumes you know what you're doing, and it will just follow your instructions. It will copy signed variables into unsigned variable locations. and it will copy sort of alphanumeric variables to numeric. And I'll go more into the trusting but not verifying inputs in a while. These are the types of variables. I'll show you how things can go horribly wrong with these. There's an alphanumeric variable, which is normally always depicted as pic x, and then its length in braces afterwards. A numeric, which is pic 9, and then its length in braces. And a sign numeric, which would be pic S9 and its length in braces. So one of the ways you can get mismatched variable types is this, what you can see here as a programmer's just assumed that somebody will type numbers into this alphanumeric field. So that pic x7 is then being copied into a signed integer at some point. The code that copies that alphanumeric variable into the numeric variable just assumes that you meant that. Any character digits will be transformed into hex and forced to be a number as they're copied across. As I said, there's some things that we all hate to see mixed together, and that signed and unsigned digits are one of them. It does not have the same level of horror as doing that in C. You can see here that's pic S9 variable being declared and a pic 9 variable being declared, both the same length. When that signed variable is copied into the unsigned variable, as it is there, then it will just be transformed into unsigned. Whether it was negative or positive, it will just be positive. And mismatch lengths, it does not handle these the same way as C. As you can see, there's a length 5 numeric being copied into a length 4. It won't go past and overwrite whatever else it is next. It will just truncate it. And so you will just get a shorter numeric variable, which, again, is that sort of thing I was talking about earlier. Somebody has just decided 5 digits as future-proof. Somebody else has decided 4 digits as future-proof. So through the miracle of inflation, there could come a day when somebody loses the first £10,000 of that amount being copied. There's a command called accept, where that will just accept whatever input comes in. A lot of the time in the old world, where you would be using these applications in a sort of terminal, it would be impossible to use, I guess, alphanumeric characters. You'd be restricted to numeric in some fields, or some fields would have certain lengths. It becomes more of a problem in newer systems or on a modern network, where you can just replay or intercept traffic and modify it, because you do find these things still using clear text because of those older assumptions. That trusting input takes us on to something, I guess, that you might not expect. You might traditionally associate SQL injection with web applications, but it is possible in COBOL, where you can build up dynamic SQL statements and pass them to some DB2 database. And if user input hasn't been checked or restricted, then it will sort of result in this, you being able to compromise the DB2 database at the back end. And for added fun, DB2 does allow you to concatenate SQL statements with a semicolon and does have a comment character that lets you safely eliminate the rest of the SQL statements. In the past, for a lot of these, the main defense would have been in the terminal where the input field was limited to a certain size, and so you were just kind of stuck with this field that's only numeric and limited to 10 digits or 8 digits. Anyone who's privesced on AS400 will be familiar with the frustration of only being able to steal £99 million. And it looks like this in COBOL code. You'll get that accept statement accepting the variable. And then if it is vulnerable, there will be that concatenation there of the strings along with the user inputs. Moving on from one thing we didn't expect to another, it might sound like buffer overflows are one of those uninformed statements you hear in movies. I'm sure nearly everyone in the room has improved a movie for the friends and family by telling them the mistakes in the hacking or IT sections. You can get buffer overflows within COBOL, but they're much less exciting than C and C++. It does not have a stack in the same sense that C does, so you will not overwrite instruction pointers. It just happily does the safe thing of truncating the data and just cutting off anything that would have been an overflow. As part of your code review, you can, as well as pointing out the mismatched variable lengths that I was discussing, you can sort of recommend, if they dare to change the 20-year-old code, you can put in an on-overflow sort of routine to handle the error and to sort of do something about that mismatch in lengths, whether it's accidental or deliberate. The reason that the overflow doesn't or overwriting memory doesn't do any damage on mainframes, they don't have a stack where data and instruction pointers and everything just happily all gets put together like in C. They've got some logically complex kind of a stack, but it's only variables. All the instruction pointers kept in some separate place, and it's very overflowing a variable or overwriting that kind of stack data will not disrupt the running of it. It will just disrupt the data. I'm not saying that's good. I'm just saying it's less dangerous. I realise this is turning into a list of things you didn't expect to be on mainframes, but you can have self-modifying codes as well in COBOL, where if you ever see the statement alter proc1, proceed to proc2, that will dynamically patch the next go to proc1 with go to proc2 at runtime, which makes it kind of difficult to read the codes. And there will be lots of go-to statements. That was considered okay years ago. So you might find yourself trying to follow paths through various spaghetti kind of codes. It's going to be tough to actually ask somebody to put less go-tos in there because these things have been functioning so well for so long. You're more likely to have to just tell them to document it properly. But yes, you can find wacky things like that as you work through it. So those go-to statements and entry point work as your way of following things through in the code. really it's more a case of recommending to people to document it properly rather than trying to unspaghettify it. A lot of the file management, like that's back into the trusting user input thing I spoke about earlier. The display and open verbs are used to handle the files. And so that would read in input from the files. And like C, it will just assume you meant whatever you've done. It will just happily take whatever input it's told to and put it wherever it's told to. As I said, Veracode and checkmarks will find a lot of this stuff and will be very helpful for doing this. My latest version of VCG, or one of the more recent versions, does do some COBOL checks. As I said, I'm not saying it's better than checkmarks or Veracode. I'm just saying that it's free. I will show you a quick thing of it in action. It just needs to be told which language it's looking at and pointed in the direction of some vulnerable COBOL code. This, I don't think, is intentionally vulnerable COBOL code. It's stuff I found from COBOL tutorials on the web, which I don't know whether you should read into that the tutorial code is unsafe, or that people are being taught badly, or that those assumptions that people use aren't so bad. But as you can see, that tutorial code has a vast amount of unsafe variable management things, strings being copied to different length strings. And you can just get VCG to take you to the line that it's identified so you can check manually that it's correct. Fairly pointless screenshot because you've just seen it running, but that's what your results will look like. Basically, my main aim was to automate the hard parts, where looking for mismatched variable types when they're being copied to one another. The main reason a lot of that is there is because it's so hard to find just by looking at it yourself. So that takes the hard work of that part out for you, and you're just left with trying to follow the logical paths through a load of go-tos. There are obviously going to be some need to report some of this, and if you get any imposter syndrome about, like, should I be reporting this, COBOL's weird, you'll find that a lot of the people there don't understand it either. There'll be 2 or 3 people, I guess, looking after all this, but with a manager younger than the codes. But understanding documentation future-proofing is like one of the things you will want to speak to people about. Making sure that that program ID, the identification section, all that stuff makes sense, nothing's outdated, and it explains things properly. For them, it can be as helpful to them as to anyone who comes to maintain it in the future, to start understanding it properly and to start putting comments in to get those program IDs should match the file name to make sure that's in place. And the important thing, again, going back to this assumption-based stuff, to make sure the executable code is in an execute-only library on the mainframe, just to stop anyone going through and digging through the codes. If anyone has the skills to find those SQL injection things and find out how to go in there and have their own bit of fun out of ours. You generally get some resistance to changing it, or some, I guess, lack of acceptance that there could be anything wrong, because these systems are normally been running fine for between 10 and 30 years. And your sort of duty in documenting it and reporting this is to explain the stuff that hasn't gone wrong yet but could go wrong in the future, where I guess a 3-digit variable has been designed because it was traditionally holding an amount of money that was only 2 digits, and then somebody's copying 4 digits in. Inflation, especially rapid inflation and rising prices of financial products, can start to push those amounts into directions where they become dangerous. And there is always that risk that somebody's got to look at this, make sure those variable lengths are big enough and that they do match. And there's been some other thing that I talked about. Traditionally, the mainframe's defense was a locked door. And the protection from malicious files was just that nobody could access the network, or nobody could access the terminal without a password. So your report would generally have to explain how intercepting tools can pick this stuff up. You might find occasionally, I think there's some places where this sort of mainframe or mini computer back end is still sitting there and operating, but people have been given some VB front end to access it, so that you can always sometimes find this way to do the SQL injection or passing the malicious file through to the back end, just because the way the front end works has changed. So I guess the main summary of all this is that whatever you might have thought, the language is far more readable than you would expect. It's not weird or obscure. I know I keep reiterating this, but things that have run safely for years can have a lot of the time you'll find in mainframes and mini computers, it's run safely for years, but it might be very vulnerable. It's just that people don't, it's only accessible internally within an organisation, and there's not always that much understanding of how to compromise it. It would take somebody with certain skills to be working on there in the internal network who wanted to compromise it and was satisfied with only stealing £99,999,999 or dollars. But you can get a lot of fun out of looking at this stuff. You can find stuff that no one else has found when you're code reviewing things, and make you feel smug and self-satisfied. And you get to see green text on a black background. Everything looks like Hollywood hacking, so it all looks cool as well. Any questions? Rory?
Have you tried looking at whether LLMs are any good at understanding COBOL code?
Yeah, I tried to, I said, convert this COBOL to C for me to see if it would keep the errors. And it corrected them and lectured me about copying mismatched variable types or copying signed to unsigned. And Dave?
The truncation, so integer truncation, so is that sort of like the COBOL version of the integer overflow? So I get 900 million pounds and then I add 1 and now I've got 1 million.
Yes, it's I forget which end it truncates for, so you might get 0 rather than 1 million. Yes. Well, worse for somebody.
I'm guessing it uses Harvard architecture, so the heap separate
as
well, so you can't do a heap overflow.
No.
Yeah.
I'm sorry, Jamie keeps putting his hand up.
So where's the, because obviously now there's GitHub and various things, where's the central source of truth? How do people make changes without changing prod?
When I worked at a financial organisation, they had 2 mainframes, I think, or 3. And they did fairly well. I guess not many people do this, but they would sort of back up each night from one mainframe to the spare mainframe, and they'd have a sort of prod mainframe as well. And it was considered so sort of sensitive or vital that they'd once a month practice restoring from nothing. And
actually, just a quick follow-up on Dave's question. So I think you mentioned that you would have to write a custom function to even catch the overflows as well. So there wouldn't be an error that would be erased? Or?
Yes, it's like C. It just trusts you. It decides like, you're adding signed to unsigned. You must have meant that.
Yep. You were talking about interoperability. Have you found any bugs with like character encoding? Because I know mainframes tend to use
EBCDIC. No, I guess not. I mean, I guess the main thing I've found in relation to the encoding is that people look at it in Wireshark as if it's with ASCII as the setting and assume it's encrypted, and it isn't. So, yeah.
I was just thinking about the locked room and the trusting user input. Is there any sort of application firewall or anything like that that's been considered in terms of acting as that virtual locked room parsing the input?
I'm going to have to plead ignorance on that. I don't know. Yeah.
Just in terms of like the experimental and learning process of being familiar with technology, how easy is it to like prepare an environment, like virtualizing small mainframes, using COBOL, or finding samples of code which is indicative of the code that you might perform as far as as well?
I don't know where you might get one. I know a couple of people who sort of had virtualized mainframes. The VMs were not small. But it was virtualized, and you could do things. Yeah.
I'm striking a memory of that. You'd have to Google.
Yeah.
And I've read something, I can't remember.
I mean, somebody has got online a virtualized, a sort of AS400 that you can practice on. But, I mean, they are doing that to be nice, so it's not really playing nicely to start trying to break it.
How would one then break into this industry?
Specifically mainframes or?
Specific code use of mainframes.
I guess getting some basic understanding, and I'm sure there's no bug bounties on there, but you can find those tutorials online, and once you've had some look at like trying out your code in a virtualized online environment, and you've sort of managed to compile something, done some code, and looked at one virtually, if you're working at a consultancy, you're probably already better than most of the people you're working with, and probably at some sort of level where you can go in and try it for a client. The real sort of risk I would advise, if you're going to do it at a client system or like with somebody, you as partnering somebody more experienced, is to learn the keyboard shortcuts before, so that you're not, because they're nothing like regular keyboard shortcuts. And so if you're hacking somebody's system and criticising their stuff and writing a report at the end, you don't want somebody to know that you don't know the keyboard shortcuts.
There's an emulator called
Just a bit of information for the pen testers in here. You can see things running on mainframes where one way might be talking acidic. When the response message comes back, it's been formatted in ASCII. So watching out for that one. And the question on the virtualization, Ian Coldwater and Big Indian Smalls.
Yes, they have.
And they were talking about where you could get hold of a ZEOS emulator and run it on stuff. So that's it. You need to go and look it up on YouTube. But there's a big thing out there on that. So they did the container escape thing.
Yes.
Yeah.
Thank you.
There was also a story about a guy who found a mainframe for sale on eBay, so you can't just also buy them.
They all quite big.
Yeah.
And they do require a lot of power.
Yeah. And you might find if you buy one online, the actual hardware isn't that expensive, but you have to license the operating system, and it can cost more than the hardware. I'm not trying to destroy your fun, but that is something to be careful of. Anyone?
Okay. I've got one final question. Is it necessary to have a mainframe Google virtualize the mainframe to carry out these activities? And actually just
No, I think I've seen online sort of tutorials for COBOL where I don't know what it's doing at the back end, but it does sort of, I think tutorials points might be the one, but they have sort of COBOL tutorials and a way of simulating some compilation for you and telling you what it executed, what the output was. So you can legitimately properly practice like that, yeah.
okay. Thank you very much.
JD Sports still use COBOL. If you wanted to
credit card.
but it might be easier to get into JD Sports. They have a boot camp because they hire people and no one knows it.
You serious?
Yeah.
Gosh.
There was one problem when they go outdoors. You go outdoors, it does not use COBOL. And all the go outdoors stuff was. We've got one example, so we better.
You might choose to because their head office is there, and I think they want a lot of staff to be able to go in. If you use once a week, maybe more. A lot of friends that work with JD.
I don't think it works much.